Okay, so welcome back. We're just going to explore a little bit more the difference between linear and quadratic equations, everything from the actual equation to the table of values to the graph. So with our first side over here, we're going to be looking at the equation y equals 2x minus 1. Now, by looking at this equation from our previous lesson, we know right away that this is definitely y equals mx plus b because that x has a 1 with it. As the degree, this is linear. But we're going to do some exploring and see really the finite differences between linear and quadratic. So the first thing that we can do is make a table of values. So I've given you some random points here of -2, -1, 0, 1, 2. So what we're going to do is we're going to replace x inside of our equation with all of the different variables. So the first one that we're going to replace x with is -2. So now you're going to take out your calculators and we're going to work through the equation replacing x with -2. So 2 multiplied by -2 equals -4 minus 1 equals -5. So that's my y. Now we're going to move on and do -1. So now instead of a -2, we're going to replace x with a -1. 2 times -1 is -2 minus 1 is -3. Now we'll replace x with a 0. See what we're doing here? We're just going through the list, the table of values. We're replacing the x value with what it says x is. X is 2, -1, 0. And now in our equation, we're putting in that 0. So 2 times 0 is 0. 0 minus 1 is -1. And then we'll write out what the output is, what the y is. Okay, so then we'll finish it off here. 2 times 1 is 2. 2 minus 1 is 1. 2 times 2 is 4. 4 minus 1 is 3. And now we'll do some exploring. So we know that this is linear already, so we can already anticipate what the answer is going to be for my first difference. Are they going to be all the same or all different? Constant or different for the first difference if it's linear? That's right, they should all be the same. So let's make sure that they're all the same, that they're all constant. Let's subtract from the bottom up. 3 minus 1, 2. 1 minus -1, 2. -1 minus -3, 2. -3 minus -5, 2. They're all the same. That means that this is definitely linear. But now let's explore the other side. The other side, we're dealing with an x squared as my highest degree. So what do you know about this equation? It's a quadratic. That's right. So now we're going to replace the variables 0, 1, 2, 3 in the same way that we did for the linear equation. Only now when we replace it, we're going to replace that x in 2 different places. So we have an x that's being squared, and then we have an x that's to the power 1. You need to make sure to replace the x, so for this first one it's a 0, twice. Now if you have a 2-line calculator, you can do this all in one step. If not, you're going to have to use BEDMAS to solve. That means that you solve for each of these individually, and then you put them together for BEDMAS. For me, I'm just going to do 0 squared minus 4 times 0 plus 3 all in one shot on my calculator. 0 squared is 0, 4 times 0 is 0, 0 plus 0 plus 3 is 3. Now I'm going to do the next one, but instead of zeros, what number am I going to write in? That's right, I'm going to replace it with now a 1. So I'm going to use my calculator, 1 squared minus 4 times 1 plus 3, press equal, and you end off with 0. Then we'll try the next one, 2. 2 squared minus 4 times 2 plus 3 is -1. Keep going. 3 squared minus 4 times 3 plus 3 is 0. 4 squared minus 4 times 4 plus 3 is 3. Now you can see the pattern here. 3, 3, 0, 0, negative 1. This forms the U shape, which we call a parabola in our quadratics. We know that it's a quadratic because I've already taught you about the equation. But now let's prove that it's a quadratic with my differences. Where are they going to be constant? The first time I subtract or the second time I subtract? That's right, from the first lesson I told you it's the second time that we subtract. So let's prove that true. 3 minus 0, 3. 0 minus negative 1, 1. Negative 1 minus 0, negative 1. 0 minus 3, negative 3. They're not the same in my first difference. Of course not, because it's not linear. But if they're the same in my second difference, that means that I'm dealing with a quadratic. 3 minus 1, 2. 1 minus negative 1, 2. Negative 1 minus negative 3, 2. Wow. They're all the same in my second difference, so that means that I'm for sure dealing with a quadratic. Remember, this is what you're going to have to do on your CPT. So now graphing these two different equations, we're going to make a straight line and we're going to make a parabola. Now to graph, remember, you're plotting points. So the first point that I'm going to plot for my linear equation is at negative 2 and negative 5. So negative 2 and negative 5. The next point that I'll plot is at negative 1 and negative 3. Then at 0 and negative 1. Then at 1 and 1. 2 and 3. This, of course, makes a straight line, which is my linear equation. The next graph that I'll make is a parabola, and we'll see how that works. We'll plot a point at 0 and 3. Then we'll plot a point at 1 and 0. Then we'll plot a point at 2 and negative 1, 3 and 0, and 4 and 3. And this, of course, makes the U shape of my parabola. You see how I've extended the lines past my last points there, and I put arrows on the end? That's because this parabola goes on forever. If I wrote down a 5, a 6, a 7, or a negative 1, a negative 2, this parabola would keep going and going to all the different x values and y values. So now let's write down some information that we know about linear and quadratic relationships as a form of a summary. So our equations for linear are y equals mx plus b, as we talked about. Our quadratic is ax squared plus bx plus c. Our table of values, we're going to notice that our first difference is constant, and our second difference is constant for my quadratics. For a graph, I'm going to be dealing with a line, a straight line at that, and for my quadratic relationship, that U, we call that a parabola. Now I just want to go through and outline some information here about identifying these important points on a graph, because our next lesson is ultimately word problems where I give you a graph and then there'll be words to describe these different points. So we know that the vertex is the turning point. It's the most important point. So I can identify that on this parabola right here. And a vertex is a point. So I got to give the x and the y value. The x value is 0, the y value is positive 4. Now, does this parabola have a maximum or minimum? In order to determine that, you're going to look at your vertex. Now, is that vertex the highest point on this parabola or the lowest point? That's right, it's the lowest point. And where does that lowest point occur at? What y value? 4. The axis of symmetry is simply the x value from my vertex. It's the line that cuts my parabola in half. The x-intercepts and zeros, these are the same. Zeros and x-intercepts and roots mean the same thing. So I want to know where this parabola crosses the x-axis. Does it cross the x-axis? No, there are none. Does it have a y-intercept? Yep, it's at 4. It crosses the y-axis at 4, which is also the maximum value in this particular case. Let's look at another graph. So let's identify the most important point, our vertex. Let's maybe put points at the x-intercepts. And let's put a point at where it crosses y. These are our most important points on our parabola. So our vertex in this case is at 3 and -1. You can see that right here with the x value being 3, the y value being -1. Does this parabola have a highest or a lowest value? It has a lowest, and its lowest value is at -1 for y. The axis of symmetry is the x value of my vertex that cuts the parabola in half, which is at 3. My x-intercepts and zeros are the same. There are 2 of them in this case. There's one at 2, and there's one at 4. My y-intercept, there's only one. There can only ever be one, and it's at 8. So that's going through and identifying some of the important points on a graph that then we can use to turn into word problems to identify the same points but give them a different meaning. And that's what we'll be doing in the next lesson.